All right, welcome to another deep dive. We've got a whole stack of Python programming tutorials to dig into today.
Yeah, it looks like someone out there is really keen on getting up to speed with Python,
Yeah.
and they've sent us a bunch of resources to kind of make sense of it all.
And they're specifically looking for a clear picture of what Python is all about, without getting lost in the weeds. That's where we come in, right? We're going to sift through all this and highlight the key takeaways, what makes Python so powerful, what it's used for, and why it's become so popular.
Exactly. And beyond just the basics, we're going to dig out some of the more surprising aspects and really give a feel for Python's strengths and maybe even some of its quirks.
All right, so let's start with the fundamentals. What is Python? The tutorials really hammer home the idea of versatility, power, and this real emphasis on simplicity and readability.
Yeah, and that readability part, that's huge, especially for beginners.
I can imagine. So much of coding is not just getting it to work, but being able to understand it later or having others be able to jump in and work with your code.
Right, you don't want to be stuck deciphering your own hieroglyphics 6 months down the line.
Yeah.
Python's often described as almost reading like plain English in some cases.
Hmm.
And the tutorials mention it being an interpreted, high-level language which supports multiple programming paradigms. That's a mouthful, but it basically means Python can work in different ways depending on the problem you're trying to solve. You've got procedural, object-oriented, even functional programming styles all possible within Python.
Interesting. It's like having different tools in your toolbox and you can pick the right one for the job. And it all goes back to Guido van Rossum, the creator of Python. I always find it fascinating to know a bit about the people behind these languages.
Oh, absolutely. I mean, he started working on Python as a kind of a side project. He was actually focused on a different operating system project at the time, but he saw limitations in the existing programming languages and set out to create something better. And it's pretty amazing how Python has evolved since then. I mean, it wasn't originally designed for things like data science, which it's now a major player in.
Right, right. Talk about an unexpected success story.
Yeah.
Now, the tutorials also make a point of mentioning that Python is case sensitive. Seems like a small thing, but I bet it trips up a lot of newcomers.
Oh, it's a classic. One wrong capital letter and your entire program can come crashing down.
Yeah.
It's definitely something to be mindful of from the get-go. And while we're on the topic of things that might seem a bit unique to Python, the tutorials really stress the importance of indentation.
Oh, yeah, that's a big one. Instead of using curly braces like many other languages to define blocks of code, Python relies on consistent spacing.
Exactly. And at first it might feel a little strange, but it really forces you to write clean, readable code.
Yeah, it's almost like the language itself is encouraging good habits. So moving on, the tutorials give a really handy breakdown of where Python really excels, right? It's not the be-all and end-all for every single task, but it's definitely dominant in many fields.
Yeah, let's dive into that.
There's this table that lists Python as the top choice for things like machine learning and AI, specifically mentioning TensorFlow and PyTorch. I mean, those names are everywhere these days.
Yeah, and Python's popularity in these areas is a great example of a sort of a positive feedback loop. It was relatively easy to learn and had this growing community, so people started building these amazing libraries like TensorFlow and PyTorch. And that in turn attracted even more people to Python for those specific tasks, fueling further development and creating this really rich ecosystem.
Makes sense. It's like the more people use it, the better the tools get, and then even more people are drawn to it. So besides machine learning and AI, data science and analytics is another big one. Pandas and SciPy get shout outs there, and those are like the core tools for data wrangling, right?
Absolutely. If you're dealing with data in Python, chances are you're going to be using Pandas and SciPy quite a bit. And it's interesting to see how those tools have shaped the way data analysis is done now.
Right. And the list goes on. Cybersecurity and ethical hacking have Python as a first choice, which I found kind of surprising. And then you've got automation and scripting, cloud computing, and DevOps. It sounds like if you're dealing with repetitive tasks or need to manage complex systems, Python is often the way to go.
Exactly. And it speaks to Python's versatility, right? It's not just for one specific niche. It's got applications across a wide range of fields. Now, it's equally important to look at where Python isn't necessarily the leader or where other languages are just as strong, if not stronger, gives you a more balanced perspective.
Yeah, like in web development, Python's got some great frameworks like Django and Flask, but JavaScript still reigns supreme on the front end, right? And when it comes to system programming and building operating systems, C and C++ are generally preferred. the tutorials point out that Python being interpreted and potentially slower is a factor there.
Right? It's kind of like the difference between building a house and building a rocket ship. For something like an operating system, which needs to interact directly with hardware and run super efficiently, you need a language that's really close to the metal, like C or C++ bus back. Python is a bit higher level, so it's not always the best fit for those tasks.
So game development is another area where Python can be used for scripting, but for those graphically intensive AAA games, C++ and C# are usually the go-to because of their performance. And it's a similar story for embedded systems and the Internet of Things, or IoT. There's MicroPython for some of those smaller devices, but C and C++ still dominate in those resource-constrained environments.
And mobile app development isn't really Python's strongest suit for native user interfaces. And in high-performance computing, where speed is absolutely paramount, you'll often see languages like C and Fortran used. Even in blockchain development, while you can use Python, Solidity is kind of the standard for platforms like Ethereum.
It's interesting that the tutorials use this phrase, "can do the same," for a lot of those areas. Like, yeah, Python could technically be used, but there might be better, more specialized tools for the job. But I guess even in those situations, Python's ease of use and the large community supporting it could still make it appealing, right?
Absolutely. If a team is already familiar with Python and they need to get something up and running quickly, they might choose Python even if another language is technically better suited. It often comes down to developer familiarity, time constraints, and the specific needs of the project.
That actually leads us nicely into this whole idea of interpreted versus compiled languages, which the tutorials also dive into. This feels like a really fundamental concept to grasp when you're learning about programming languages.
Absolutely. So imagine you have a translator. With an interpreted language, like Python, the translator reads your code line by line to the computer and executes each instruction immediately. This means you can kind of stop and see what's going on at any point, which makes debugging easier.
And the tutorials list JavaScript, PHP, and Ruby as other examples of interpreted languages.
Right. Now, with the compiled language, it's like the translator takes your entire program and converts it into this machine code, which the computer understands directly before it even runs.
Ah, so it's like having a pre-translated document. No need for the interpreter to work through it line by line.
Exactly. This compilation step takes some time up front, but then the resulting program usually runs much faster because the computer is just executing those machine instructions directly. C, C++, May, and Java are classic examples of compiled languages. Java is a bit of a hybrid. It compiles to something called bytecode, which then runs on a Java virtual machine.
And I noticed a little rocket ship icon next to the section on interpreted versus compiled languages in the source material. It's a good visual cue, right? Like compiled languages are generally going to be faster because there's no interpreter slowing things down.
Exactly.
Yeah.
There's a trade-off, right? Interpreted languages are often quicker to develop and easier to debug because you can see what's happening as the code runs, while compiled languages tend to offer better performance once they're built.
So it's a balancing act, really. Depends on what you're prioritizing. Now, the tutorials move on to some essential tools and concepts for anyone starting out with Python. This is where it gets really practical, right?
Totally. And they start by introducing integrated development environments, or IDEs, which are basically souped-up text editors designed specifically for coding.
Okay, and they suggest looking for the best Python IDEs, which implies there are a bunch of options out there. What makes one IDE better than another?
Well, some might have better code completion features, which basically predict what you're trying to type and save you a lot of keystrokes. Others might have more powerful debugging tools to help you find and fix errors. And then there are things like integration with version control systems, which are essential for collaborative projects. It really depends on your personal preferences and what features are important to you.
So it's worth exploring different IDEs to see which one feels right. And the tutorials also highlight the importance of knowing how to check what version of Python you have installed. That sounds pretty basic, but I guess it's important for compatibility and stuff.
Oh, absolutely. Different projects might require different Python versions, and some libraries only work with specific versions. So knowing how to check that using the command line is a good skill to have. They show you how to do it with Python version or python-mpipfreeze.
Okay, so that's a command to commit to memory. And speaking of things you'll probably use all the time, they also mention the ability to list all the libraries you have installed using %pipfreeze in Google Colab or python-mpipfreeze in other environments.
Right. And libraries are essentially these pre-written chunks of code that extend Python's capabilities. You can think of them as add-ons that let you do all sorts of things, from working with data to building websites to creating games.
So, knowing what libraries you have available is key as you start tackling different types of projects. The tutorials also briefly mention comments, both single and multi-line date functions, and doc strings. These might seem like minor details, but they're really important for writing understandable and maintainable code, right?
Oh, absolutely. Especially if you're working in a team or even just coming back to your own code after a while. Good comments and documentation are a lifesaver. It's like leaving a trail of breadcrumbs so anyone can follow your thought process.
Yeah, it can be really frustrating trying to decipher poorly documented code. Now, the tutorials also introduce Kinter, which is Python's built-in library for creating graphical user interfaces, or GUIs.
Right, and it's a great way to get those aha moments when you're first starting out because it lets you build actual windows and buttons and things you can interact with. It makes the whole coding process feel much more tangible.
And they point out that Tkinter is relatively intuitive to use, which is encouraging for beginners who want to see their code come to life in a visual way. And they touch on pandas again, this time specifically as a tool for data analysis, along with Beautiful Soup for parsing HTML and XML, which is essential for working with web data.
Yeah, those are definitely key libraries to be familiar with if you're interested in the data science side of things. Now let's talk about IPython and Jupyter Notebooks. These seem like particularly powerful tools, especially for data science and research.
They definitely sound intriguing. What makes them so special?
Well, IPython is like an enhanced version of the standard Python interpreter. It gives you all these extra features for interactive computing, like better tools for data visualization, high-performance computing, and something called introspection, which basically means you can examine the properties and functions of Python objects more easily.
Okay, so it's like taking the regular Python interpreter and giving it a supercharge.
Exactly. And it integrates seamlessly with Jupyter Notebooks, which are these browser-based environments where you can mix code, text explanations, mathematical formulas, and even visualizations all in one document.
So it's not just about writing code, it's also about documenting your thought process and presenting your findings in a clear, interactive way. That sounds really useful, especially for research or data analysis. And they mention magic commands in IPython, which are these commands that start with a percent sign or 2% signs. What are those all about?
Think of them as shortcuts for common tasks. Some might be for running system commands, others might be for timing how long your code takes to run, or even for integrating with other programming languages. It's all about making those common interactive tasks a bit easier.
So it's all about boosting productivity and making the interactive Python experience more user-friendly, especially when you're dealing with lots of data or complex experiments. And, this whole conversation highlights how Python isn't just about writing code, it's about this whole ecosystem of tools and libraries that make it such a powerful and versatile language.
Absolutely. And speaking of real-world challenges, the tutorials wrap up with a problem posted by a user, which demonstrates that learning is an ongoing process. Sometimes you run into issues that even the tutorials haven't covered.
And this particular problem seems pretty tricky. A user describes building a hotel management system using Python and SQLite 3, which is a lightweight database. Everything works fine when they're developing it, but after they use PyInstaller to convert it into a standalone executable file, any data they enter gets lost when they close and reopen the application.
Yeah, that's a pretty major issue for a hotel management system. And the interesting thing is that the tutorials don't provide a solution, they just present the problem.
Which is a good reminder that tutorials can only take you so far, right? Real-world development often involves digging deeper and troubleshooting these unexpected problems. But it also shows how important it is to have a solid understanding of the fundamentals and to be comfortable seeking out solutions beyond those initial learning resources.
Exactly. And this is where things like online communities, documentation, and just good old-fashioned problem-solving skills come into play.
It's like the tutorials give you the tools, but then you have to learn how to use those tools to build something real, and that often involves dealing with unexpected challenges and figuring things out as you go.
Right. And those challenges, they can be frustrating, but they're also where the real learning happens.
So to wrap up this deep dive, we've gone through a bunch of Python programming tutorials and really tried to distill the essence of what Python is all about. We've seen how its focus on readability and versatility has made it a powerhouse in fields like AI and data science. And we've explored the essential tools and libraries that make it such a productive language to work with.
And we've also seen that learning Python, or any programming language for that matter, is a journey, not a destination. There's always more to learn, more problems to solve, and more creative ways to apply your skills.
And on that note, here's a final thought to ponder. Considering Python's widespread use and this real-world problem with the executable, what other kinds of surprises or limitations might you encounter when taking a Python application from your development environment and putting it out there in the wild? And where would you turn for help or guidance when those unexpected roadblocks pop up? It's a good question to keep in mind as you continue your Python journey. Thanks for joining us on this deep dive.